Hi, I'm Vinodh, Assistant Professor in the Department of Aeronautical Engineering. Today we are going to discuss a topic on fundamentals of thermodynamics, which comes under the course of Aero Engineering Thermodynamics. What is thermodynamics? Thermodynamics is a branch of physics which is concerned with heat and temperature and their relation to the work. That is nothing but the heat transfer in various places. So what is the difference between heat and the temperature? Heat is nothing but a form of energy, and temperature is the measurement of hotness or coldness of a body. Whereas heat is a path function and temperature is a point function. Where the point and path defines as when you draw an XY graph, where the X and Y determines as a point, and the point and the path line drawn towards the X and Y is determined as path, where the heat comes there. After that, we have to discuss a main topic, that is fundamentals, that is thermodynamic system, where here the most important was three categories, that is system, and surrounding. System is nothing but the quantity of matter or the regions in a space chosen to state, where surroundings or the outer resistance and the boundaries are nothing but the thing that divides both the surroundings and the system. And again, the types of systems, there are three types of systems. One is open, closed, and another is isolated system. Where the open system is a system which allows both mass and the energy to transfer. For example, air compressor, where the both mass and the energy get transferred. And for the closed system, no mass transfer, only the energy get transferred. For example, daily life you are using bike, where the mass did not transfer, only the energy get transferred. And the last is isolated system. Here both the mass and the energy won't be transferred. For example, thermoflux, where our hot water is poured and no energy and mass will be transferred. The next topic is properties of a system. There are two main properties. One is intensive properties and another is extensive property, where intensive property is totally independent of the mass. The next what we are going to discuss is properties of a system. There are two properties mainly involved in this thermodynamics. One is intensive property and another is extensive property. Intensive properties are the properties which is independent of the mass of the system. For example, temperature, pressure, density, so on. These are not involved dependent on the mass. Whereas the extensive properties is nothing but a property which is totally dependent on the mass. For example, volume, weight, etc. Apart from this, there is a process, thermodynamic process. Mostly there are five important processes. One is flow and non-flow, and another is reversible, non-reversible, and finally quasi-static process. So the flow and non-flow. Flow process is nothing but a process where the working fluid enters the system and leaves to the atmosphere after doing work. In the system, both energy and mass crosses the boundaries. Example, turbine and compressor. Whereas in non-flow process, the same working fluid is recirculated again and again. It does not leave the system after doing the work. For example, the constant volume process, constant pressure process, and constant temperature process. Third process is reversible process. Is the one in which both the system and its surrounding can return to exactly the same state that were in by following the reverse of that. And whereas vice versa, the irreversible process is the one in which the system and its surrounding cannot return together to exactly the state that they were in. The next concept is phase. So we know that there are three types of states. One solid state, liquid, and gaseous. When it comes for the mixture, when the solid and same state, like solid to solid, they are mixing them, then it is called homogeneous. Where it mixes it in a different state, then it is called heterogeneous. And by the way of approach, thermodynamic approach, there are two types of approach. One is classical thermodynamic, or it is called macroscopic approach, and statical thermodynamic, or it is called microscopic approach, where the name signifies that macro and micro. We know that when I do an experiment, then values what we have taken directly out for macroscopic approach. by doing some formulae, and then we get a then it is called the microscopic approach. So finally, laws of thermodynamics. There are three main laws. One is zeroth law, first law, and second law of thermodynamics. These are invented to intimate the concept of thermodynamics. First, zeroth law of thermodynamics. It explains the concept of temperature. Zeroth law states that if two thermodynamic systems are each in thermal equilibrium with the third one, then they are in thermal equilibrium with each other. For example, they have in thermometer. This is called zeroth law of thermodynamics. Next is first law of thermodynamics. It states that when a system undergoes a thermodynamic cycle, the net heat supplied to the system is equal to the net work done by the system. Where here, due to some limitation, this law is violated, and they invented the second law of thermodynamics. The reason they have violated this law are mainly due to three main reasons. They have first, they didn't show that in the first law, they didn't give any information about the directions. Secondly, it does not fails to give a feasibility of a process. Third, it it is impossible to convert the heat energy which is supplied to the system into an equivalent amount of work. So, the second law of thermodynamics has been invented. So, this law contains two forms. First form, Kelvin-Planck statement, and second form is Clausius statement. Where the Kelvin-Planck statement gives a statement that the amount of heat supplied to the system will not fully converted into work. Some amount of energy will be liberated to the atmosphere. That is, heat will be rejected to the atmosphere. It precludes the perfect heat engine. And it gives an example for the heat engine. That is Kelvin-Planck statement. The next one is Clausius statement. Here it is not possible for a heat to flow from colder body to warmer body without any work. But we can transfer heat from the hot body to cold body without doing work. But when we have to transfer the heat from a cold body to hot, there are some external force has to be applied, like refrigeration, air conditioner, or some heat pumps. So example, here are heat pumps and refrigerations. And these are fundamentals of thermodynamics. Thank you.